Okay, I had a lot of trouble with this, and if you guys had actually seen how many videos I made and deleted over this one, you would really laugh and feel better about yourselves if you're struggling too. Okay, so here's the key to this one. It was really hard to figure out. What if we let u equal 1 plus square root of 2x? One thing I'm going to do is come over here right now before I go any further and substitute in. I'm going to come down here. I'm going to come up here and take the derivative of u in a minute. But if you look at this, what I'm going to do is rearrange it a little bit. I'm going to subtract 1 from both sides and get u minus 1 is the square root of 2x. So when I've got square root of 2x down there, I'm going to replace it with u minus 1. Okay? Now I still got to get rid of dx, so I still got to figure out what dx is, so I still got to take du. Okay. If I write u as 1 plus 2x to the 1/2 power, when I take the derivative, that's going to be let's see, if you subtract a half from the derivative of 1 is 0, right? If I subtract 1 from 1/2, that would be negative 1/2, so I would end up with 1 over square root of 2x dx. Okay, so just dropping that down, okay? Now, what you could do, I'm sorry, that was du, I took the derivative. I can cross multiply here and get dx equals, I'm going to have to come down here. Let's do this a little separately. Ran out of space. Dx over 1, okay, is dx, equals square root of 2x du. Well, what is square root of 2x in my substitution? It is u minus 1. So this is going to be u minus 1 du, okay? So in order to get the dx, I'm going to replace it with u minus 1 du. Okay. Now, if I have that, let's clean up the, okay, I'm going to put u minus 1 du on top. And on the bottom, I have 1 plus u minus 1, which is just u. So that ends up being the integral of u over u minus the integral of 1 over u du. Well, u over u is just 1. I should put a du with both of them. So the integral of 1 du is just the integral of du, which is just going to be u, minus 1 over u would be ln u plus c. So I took that integral already, but I'm going to have to put u down here at the bottom. Okay, so if we go on to of u is u, and then I had plus ln u. Oh no, it was minus ln u, wasn't it? Because it was a subtraction sign. U minus ln u plus c. Well, what was u? U was 1 plus square root of 2x minus ln of 1 plus square root of 2x plus c. And that would be my integral. All of that is there, so I just need to replace it with d. Oh, I'm sorry, I didn't turn the recorder on. We're doing number 35, and if you look at this problem, if you write it down and look at it, if you let u be the denominator there as secant x minus 1, and you look up the derivative of secant x, because the derivative of negative 1 is going to be 0. The derivative of secant x is secant x tan x, and that's exactly what we have on top. So it works out really nicely. Your du would be secant x tan x dx. So I'm going to replace all that red with just this du right here. So if that is the same thing as ln u plus c. And if we go substitute u back in, that's just ln of secant x minus 1. We use the absolute value sign plus c. We use the absolute value sign to make sure that we know that we don't want to plug a negative number into a natural log, because you can't take the log of a natural log of a negative number. I'll eventually get it out, guys. Okay, let's go to 33. 33 is the integral of cosine t dt over 1 plus sine t. Okay, if you let u equal the denominator, 1 plus sine t, that's kind of something we're starting to see a lot here, then du, the derivative of 1 is 0. The derivative of sine t is cosine t dt, because we don't know what the derivative of t is with respect to u. So if you look, that's what I have right here. So I'm going to rewrite the integral as du over u, which would just be ln u plus c, but we just need to go back and substitute our u is 1 plus sine t. So it ends up being pretty nice. Let's look at 31. Let's try to cram as many on here as I can. Cosecant 2x dx. Okay, so what I'm going to do here is I'm actually going to let u equal 2x. Then du would be 2 dx. Okay, so if I want to get 2 dx, so let's see, this would be cosecant u, and in order to get the 2 here, right now I've just got dx, and I need the 2 dx. So I'm going to put the 2 in here with it, and I'll multiply by half out front, so I really haven't changed the value at all. Okay, so now I can say that's the integral of cosecant u du. Well, what is the integral of cosecant u? If you go look it up on your chart, that is long. Negative ln cosecant u, not the derivative, the integral, sorry, the integral of cosecant u du would be, let me come down here because that's just, I can't even read it myself. That would be a half times the actual integral. If you look it up on your formula sheet, it's negative ln cosecant u plus cotangent u plus c. And we could call that C1 because in a minute we're going to distribute that a half, and we'll call the new constant C because, you know, a half times the unknown constant, still an unknown constant. Okay, so that's equal to, putting stuff back in, a half times, all we have to do now, we want to distribute the half, and I'm going to replace the u with the 2x. So cosecant 2x plus cotangent 2x, and then we're just going to absorb the 1/2 C1 and just call it C. And we got to make sure we don't get a negative log. So remember, we've still got these absolute values here that I'm darkening a little bit. Should have had one here, and I'll put a parenthesis sign. These should be the absolute value signs that you see me darkening here, because we can't take the log of a negative number.